6.6 magnetic force on a current carrying conductor. When a current carrying conductor is placed in a magnetic field B, a magnetic force will act on that conductor. So situasinya adalah kita ada satu wire yang mempunyai arus. Kita letakkan wire tersebut di dalam kawasan magnetic field, akan ada magnetic force yang exert on that conducted wire. So to find the magnetic force exerted on that current carrying conductor ataupun on that wire, we use this equation F equal to BIL sin theta. So when you are going to use this equation, bila ada wire yang diletakkan dalam kawasan magnetic field dan wire tersebut ada current. Okay? Kalau tadi F equal to QVB sin theta is only for moving charge, proton or electron. This equation is for the current carrying conductor. Okay, so F is the magnetic force, I is the current, L is the length of the conductor, D is the magnitude of the magnetic field strength, and the angle right here, kalau you gunakan angle, it is the angle between I dan juga B. Ataupun sama juga dengan L dan juga B. So for this concept, we use left hand rule, F, B, I. Or we use right hand palm rule. Okay, usually I use this one. So let's try this example. We have a current carrying conductor with current directed upward is placed in an area of magnetic field B. So what happened is there will be force exerted on this wire. So by using our left hand rule F, B, I. So I ke atas, B ke kanan. So F will be into the page. And look at the angle. This is the angle 90 degrees right here. Okay, so that's why we say that the conductor wire is perpendicular with the magnetic field. Ataupun we can always say that the current perpendicular dengan B. For this case, current is parallel with B. So the angle is 0, sin 0 is 0, so the force is 0. There will be no magnetic force exerted on this wire for this case. And then for this one, okay, so you use your left hand rule, FBI. So B is into the page, X is into the page, I is upward, so F will be to the left. For this case, I is downward, B is into the page, F will be to the right. Example 6.6, a wire of length 20 cm is placed perpendicular to a magnetic field of magnitude 0.4 Weber per meter square. Calculate the magnetic force on the wire if it carries a current of 12 ampere. So to find the magnetic force, for this case, we can use F equal to B I L sin theta. So B is 0.4, I is 12 ampere, L is 20 cm, convert it into meter, and sin theta, the angle is 90 degrees because perpendicular. B, what is the magnitude of the force on the wire if its length becomes 30 cm and carries the same current as in equation A? So we use the same equation, F equal to BIL sin theta, but we change the value of L. For C, if the force on the 20 cm wire is 60 times 10 to the power of -2 Newton and carries a current of 12 ampere, find the magnetic field strength. So we also use F equal to BIL sin theta, but we already have the value of F. We substitute the value of I and also L to find the B. So for question A, we use this equation, we will get 0.96 Newton. For question B, the same equation, we replace L daripada 20, we change it to 30 cm, then you will get 1.44 Newton. And for question C, use the same equation, but we already have the force, we substitute L, then we want to find B, which is 0.25 Tesla. Example 6.7, a current 18 ampere is placed along the positive x-axis and perpendicularly to a magnetic field. The conductor experiences a magnetic force per unit length of 0.12 Newton per meter in the negative y direction. Determine the magnitude and direction of the magnetic field strength in the region through which the current passes. So magnetic field strength, we want to find B. So we already have I. We also have, this one is F per L. So we want to find B. So by using the equation F equal to ILB sin theta, kita bawa L ni to the left because we have the value of force per unit length, which is 0.12. We substitute the current, the angle is perpendicularly, so we will get the magnetic field strength. To determine the direction of magnetic field strength, so we use our left hand rule FBI, then we will get the direction of B.